Now we're going to look at logarithmic equations, and it turns out that equations with logarithms are actually easier than equations with exponentials. In most cases, that is. So, here's how we solve a logarithmic equation. So first of all, a logarithmic equation is an equation that has a logarithmic in it, and a logarithmic expression, that probably should say, and there's a variable in the logarithm. That's the key. All right, so that variable x is hiding in the logarithm. We got to get that x out. So first thing we're going to do is we're going to get this log by itself, and then we're going to change it into an exponential. So first thing we want to do is got to get any constants like that 3 out of there. And that leaves us with log base 4 of x plus 5 equals 3. Now we want to change this into an exponential form. That means we take the base and we swing it around, and we're going to rewrite this as 4 to the third equals the stuff that's inside the log x plus 5. And what is 4 to the third? That's something we should be able to figure out. 4 times 4 times 4, that's going to be 64. And then the last step is just to solve. Subtract 5, and so x is 59. Okay, so now we need to check, we need to make sure that when we put this number in the logarithm, that we get a number inside the log, the argument, we call it that m number. We need to make sure that that ends up being bigger than 0. All right, so for our check here, log base 4 of 59 plus 5 equals 6. All right, now the most important part here is this. We got to make sure that this actually is a positive number, and it is. In this case, it's 64. Log base 4 of 64 is 3. And so this does check out. But again, the key is to ask, is this positive? If it is, we're good. If not, then we got to throw the answer out. So let's check out some examples of solving logarithmic equations. So first step here is we got to get this logarithm all by itself. Okay, don't go trying to touch this 5. It is hidden. It is protected by the logarithm. So we can subtract 3 from both sides here. And we're going to get log base 8 of x plus 5 equals -1. Then we're going to change it to an exponential. All right, now let's see, we've got raise it to the 8th power, so this is x plus 5 equals 8 to the -1. So we've got the -1 power, I should say. And what is 8 to the -1? Well, that is 1/8. So we're going to subtract 5 from both sides. Okay, got to get a common denominator here. 5 is the same as 48ths, right? Okay, so 5 is 48ths. Just make it a common denominator out of that there. So 1 minus 48 is -39/8. Okay, well, now we got to double check that. And the question we really got to ask ourselves is this. If we take log base 8 of -39/8 plus 5, the question is this number greater than 0? And it is. So, yes. Okay, so that is greater than 0. So this does check out. All right, it's in the domain. If it's not in the domain, then we have a domain problem there. Okay, because this is 48ths, as we saw up here. 48ths plus -39/8 is 1/8, and that's that -1. So it checks out. All right. Couple more. We want to isolate the logarithm. We got to get that logarithm by itself. Don't try to touch this 3. You can't mess with it yet. You got to get the 5 out of there. The 5 is being multiplied. So we have the natural log of 3x equals 9. And now remember, this is base e. So we're going to take that e and swing it around, and we'll get e to the 9th equals 3x. So we changed it from a logarithmic equation to an exponential form. Okay, now e to the x is a decimal number, so we want to leave it alone. We want an exact answer first. So we divide it by 3, and so we have e to the 9th divided by 3. That is the exact answer there. Okay, so if we want a decimal approximation, we can go to our calculator, and e to the 9th divided by 3 gives us 2,701.03. So there's our decimal approximation. All right. How about one more here? Oh, we should check that out. Is that going to be positive? Yes, if you plug this in for x, 3 times that is going to be positive. So our domain is going to be just fine. All right, we already have a logarithm. Everything looks good there. This is base 10. So if we swing that around, this is going to be 3x squared minus 2 equals 10 to the first, which is just 10. So if we add 2 to both sides, we have 3x squared equals 10 plus 2, which is 12. Now we can divide by 3. And we got x squared equals 4. And we can square root both sides. And x equals plus or minus 2. Don't forget the plus or minus. So we have two numbers at work here. And when we plug this in, we get positive 2 squared. And then that's positive, so that's good. Everything will be positive. We plug in negative 2. Negative 2 squared is 4. Times 3 is 12, minus 2 is 10. That whole thing works out just fine. Okay, so both answers work fine. So that's the idea. All right, get the logarithm by itself and change it to an exponential equation. From there, you should have a simpler equation that you can solve pretty easily.